Hello programmers! I've got a program here that has a variable x set to 6, and I wanted to remind everyone that when you put the ampersand in front of the variable, it'll tell you the address in memory where that variable is stored. So if I've got x set to 6, then I can print just the normal variable along with the address of that variable, and then I'll use a %p because I'm printing a pointer. And the first time I run it, I get a certain memory address. If I run it more than one time, it's very unlikely I'm going to see the exact same memory address. We get a different spot in memory. I'll try a third time, and I get another spot in memory. So what we're going to talk about today is a variable type where its job is to store addresses in memory. So if I have an address in memory of this integer x, then to create a variable to store that address, then you can create a pointer. You'll create a pointer by putting a star after the data type and before the variable name. So this line of code right here creates a new variable with the name of pointer, and the data type, it's not just an integer, but it is a pointer to an integer. The only integer I've created so far is x, so if I want this to point to x's address, I can set that equal to the address of x. Alright, looks like pretty crazy syntax the first few times you see it, but let's take a look at what pointer is going to be equal to. I'll print the value, and because this is a pointer, %p would make sense here. I want to print out the value that's stored in that variable ptr. Now when I run this, I'm going to see that the address of x that I printed is this spot in memory, and that is also the exact same value that we see when we print pointer. So this line of code on line 5 successfully puts the address of x into that variable pointer. So how do you use a pointer? Well, to look at the address is not as useful as to follow that address and to be able to manipulate the data that the pointer is pointing to. To do that, you're going to end up putting a star in front of the pointer name. So I could say, well, what is the pointer pointing to? It's pointing to this integer, or %d, to print that. And so by putting that star in front of the PTR, we can get back to that value of 6. So far it looks like I'm just overcomplicating the code, but I do promise there is a reason for pointers. The reason is sometimes when you're passing large blocks of data, like an array with 1,000 items, instead of making a copy to pass to the function, it may be more efficient to work with those actual values in memory. Also, pointers allow you to get some more complex data types, like linked lists, and we'll talk about some of those later. But for now, we have to learn this crazy syntax with the stars in between the variable type that we want to point to and the variable name, and it doesn't matter whether you put the space before or after the star, but this is still a pointer to an integer, is the data type. Alright, so if I want to make changes to this integer, one way is to just deal with the variable x. Another way would be if I dereference that pointer, then I could make changes that way too. So if I were to look at that variable value after I've made the two increments, then it went from 6 to 8. We're still at the same spot in memory. We haven't changed the spot in memory. We are just manipulating what's inside that spot in memory. Alright, that's probably enough for our first lecture on functions, on pointers. That's enough for our first lecture on pointers. More in the future.